Hello, everyone. My name is Chan, as Mr. Tahir already mentioned. Today, I would like to give you some brief introduction regarding to data analytics and the application use cases in manufacturing. So, first, I would like to clarify the data analytics concept. So, this is basically a new concept. Probably you all heard about Industry 4.0. So every time we hear data analysis, data science, data analytics, what are the difference in here actually? What we can identify, data analytics is the broad field of using data and tools in making business decisions. And data analysis is not new actually. This is what we know, to check the data, to look for data, and to try to understand the historical patterns. But what we call data science is to make predictions for the future. So there is a small difference. Actually, they are very small, close to each other. But data science is, when we say data science, is basically refers for the future. I like this Venn diagram a lot. When we are talking about data analytics, basically,
yeah. Sorry to interrupt you. Are you sharing slides?
Yeah, I'm sharing my slides.
Okay, can you share it right now because it's not showing on the screen?
Let me share again. You see?
Now, yeah, I can see both. I can see your video and the slides. Please continue.
Okay, you see my slides, right? There.
Yes, I can see it. Yes.
Okay. Sorry for that.
No, it's okay.
Okay, so for data analytics, we are talking about the combination of three things. In this Venn diagram, we see computer science, math and statistics, and business and domain expertise, actually. So now, math and statistics, we are get used to it, like correlation, hypothesis testing, regression analysis. Business domain expertise is the process knowledge that we need to have. And now computer science, with the development of IoT technologies, with the development of computational power, this part of this Venn diagram helps to data science to be possible and to be separate all around to manufacturing. There are a lot of software actually that becoming popular day by day regarding to data science. Python, R is one of them, and KNIME is very important also. KNIME is a program, a software that helps us for data scientists, but requires no coding, because when I say Python or R, people get a little bit scared because it requires coding. In KNIME, by using nodes, you do not need coding, and you can develop machine learning algorithms actually. And also we have Minitab, SPSS. These are traditional, let's say, old school statistical program that help us to analyze the data in our companies. Okay, now why this is important? Because there was a very nice survey that Forbes did. 46 of the manufacturers said that data analytics are necessary to stay competitive and grow. It is crucial for success and can improve supply chain performance and increase revenue. So we need to, in our current environment, we need to take decisions based on data. Data is very, very important for us. So we need to take our decisions based on that. I want to show you a very nice cartoon. This very old one actually. I'm using this cartoon in my trainings for more than 10 years maybe. I always ask participants how many monsters you see above the surface. So basically, obviously, now here we see one monster, right? But when we look below with the data underneath the surface of the water, we can recognize that there might be three monsters waiting for us. So experience is very valuable, and we have experience, and we are giving some decisions regarding to our experience. And also in lean, as a lean expert, I always say we have to trust experience of the intellectual knowledge of the shop floor people or engineers or supervisors, whatever. But of course, every decision needs to be data driven. So there are some famous phrases regarding to it, but one of the most I like, without data, you are just another person with an opinion. So we need to base our decisions on the data. There are 4 types of data analytics, actually. First 2 are descriptive analytics and diagnostic analytics. I may call these a little bit old school now. So now when you just investigate on the historical data, when you just see what is going on, you know, we did some actions, but it is working or not. You try to understand these kind of things. This is what we call descriptive and diagnostic analytics. Now they become a little bit old school. What we have in the 3rd and 4th step, 3rd and 4th type, let's say, predictive analysis and prescriptive analytics. What is predictive analytics? Now we are, by using the past data or the current data always coming, we are trying to guess, we are trying to make predictions regarding the future. This is what we call predictive analysis. By developing regression models, by developing correlation analysis, or using even advanced analytics techniques like machine learning, deep learning, or neural networks. And the 4th step, 4th type, let's say, it is not step, 4th type is adding actions, even adding actions to predictive analytics. So you do the predictive analytics, you have a model right now, you can guess for the future, and now you have set of actions by using the power of AI or computer science. Now you are developing set of actions regarding to these parameters, regarding to these models. Besides type, except in all these types, we have 6 main steps, let's say. Now we are talking about steps. To talk about data analytics, basically what we have to do, we have to collect data, of course. We have to gather data. And data storage, 2nd step, is the 2nd one. Storing the data, cleaning the data. What is cleaning the data? Of course, we cannot use the raw data as like it is. So what we have to do, we have to organize, we have to clean, we have to remove the outliers from the data set. So we have to, we don't want that data to fall to, you know, to deceive our analysis. So we have to clean the data, and it is very important. Data scientists spend a lot of time and algorithms. There are special algorithms to clean the data. And the 4th one, finally, we are analyzing the data. 5th step, very, very important, visualization. So the role of the data scientist in the companies, I will come into that, also to guide the change management. So we don't just want to create some models. We want to express these models to our management, to the decision makers, and we want to take some actions, okay, decisions. So in order to convert everyone, in order to make them believe, we need to visualize. We need to visualize the data, and visualization is one of the most important thing for data scientists. I like this cycle a lot. So I can talk on this like half an hour just on this page, but I will try to make a brief shortly. What is the main step? What is the beginning is the business solution, business problem, sorry. So this is what we call business intelligence whole cycle, by the way. This is developed by McKinsey, this cycle, and everything starts with a problem and ends with an impact. So you see there are 4 main roles here. We have IT expertise, advanced analytics, process expertise, and change management. So this is a team job, team task. What is IT is doing? It's acquisition, storing, and organizing the data. Okay, so first we have the business problem, then according to that problem we start collecting data, then analytics come into front, and cleaning, analyzing, model developing according to that data. So now we are trying to understand the relation, and we are trying to develop the model. But of course a data scientist cannot do that by himself or herself. What do we need? We need to implement process knowledge. We need process expertise here. So companies now, as HR acquisition strategy, they are trying to hire their process engineers, and they are looking for data scientist skills on these engineers. So think about it. you know the process, and you know the data science. So these two circles might be combined together. So a process engineer that also knows data scientist and data science and can do data analytics on my data. So what do we need? We need process expertise. If these guys are separated, no problem. It's a teamwork, as we said. So one guy is telling the knowledge about the process, and the data he's guiding the data scientist. Then what do we need? After the model, we need to clarify the actions. If this data scientist and if this data study doesn't make an impact, it is useless. So it has to make an impact. It has to solve a business solution. So again, I have a nice cartoon here. So it should be balanced. You know, with a lot of data, we can be stuck in data and just not doing anything. And with less data, few data, we cannot analyze and solve the business problem. So what we have to do? We have to optimize. We have to optimize which data required for which solution. So what are the manufacturing use cases that we can implement? I will briefly talk about point by point, and I will try to deep dive in some of them in the next pages. Manufacturing execution system. Actually, it is not a new thing. It is a very, very old thing. But now with advanced analytics, now we can do some predictive modeling in MES systems. I will come into that. Now, not mostly, let's say, before 5 or 10 years, MES systems just used to visualize the data. But now they can give you predictive modeling, and we can, in the cloud, we can develop some data analytics there with the data from the MES, and they can, we can develop some models that expresses our outcome. Statistical process control, actually it is older than MES. It is developed in the beginning of the 20th century. It's a very old statistical technique. But again, with the developments in Industry 4.0, now let's say smart statistical process control is applied in the companies. Some of the companies track cycle time, and they are obtaining digital Yamazumi real time. So Yamazumi is the workload balance in assembly stations. Think that you are real time, you are seeing your digital Yamazumi and which stations are bottleneck, where should I put more effort, put more capacity, and you are identifying your bottlenecks and the wastes real time. Digital value stream map also is very popular. VSM, again, a lean technique that we implement. Now, with the help of data analytics, digital value stream mapping is becoming popular day by day. Visual inspection with artificial intelligence, again, it is combining with lean. Pocoyoke is, error proofing system, is removing error, trying to do some, develop some systems that do not let you to make some errors. Now, machine learning algorithms with visual inspections are, just trying to help us in this Pocoyoke mindset. And maybe last but not least, creating a culture of continuous improvement. So I will come into that. In Lean Six Sigma, we always mention Y is equal to function of X. So every problem, every business problem they are depending on the X's. So what are X's? X's are inputs. So what we have to do, we have to clarify the relation, the model between Y and X, and data analytics helps us a lot. So maybe you recognize I said Lean Six Sigma a lot. So data analytics and Lean Six Sigma complement each other. So they are like coming together and developing a high synergy together. And these two methods, with support of data analytics, can augment the results, your KPIs, and you can solve huge problems with these two techniques. So let's try to go one by one for some of them. Manufacturing execution systems. Actually, what is that? Maybe some of you don't know. It is just to taking the data from the machine with hardware. Edge computing is important on that hardware. What is edge computing? Instead of sending all the data to the cloud, we try to do, some of the companies try to do, they call it edge computing, some data analytics in the machine, even in the machine, because manufacturing world is faster than the social media world. This data analytics, all the industrial revolutions born in manufacturing before, steam, electric, electronics, but this industry 4.0 born in social media. And now manufacturing companies try to adapt that change. And here, what happened? Of course, we are having a lot of data in manufacturing. So sending to the cloud and making the analytics there and bringing back to the solution doesn't help all the time. We need to see that tool is wearing, and we need to see before that mistake is happened, before that tool is broken down. So what we need edge computing there, and so it is used a lot nowadays in MES systems, cloud storage, of course, and visualization. So it may. Okay. And storage also another point. Giant companies like Google, Microsoft are investing huge in cloud solutions, and in their cloud solutions, they offer data analytics services. Okay, so in their cloud, you can use machine learning algorithms, you can use artificial intelligence algorithms, even in their clouds, and even not knowing any line of coding, even not doing any line of coding. Okay, so yeah, MES systems basically visualize that, but what is new? Now they are connected to AI and ML platforms, and via edge computing, when speed is needed, edge computing is necessary, and you can develop predictive models. So think about that. Before your output becomes a mistake, or your dimensions goes in the wrong direction, you can recognize and you can change the parameters. So it is now you are one step forward. Okay, you are now one step forward than the basic MES systems. SPC, again, what is SPC? Statistical process control. Basically, what do we do in SPC, in traditional SPC? We measure and we use control charts. We do sampling. We take some samples from the we take samples from the population. We measure and we do some control charts, and we try to analyze whether it's going to be a mistake or not. How is my process going? Now, this graph is from the Haas machine provider. It's a very one of the most famous providers for CNC machines. Now, what they do, they implement some modules which are collecting data from their CNC machines, and which are processing at the same time 1 million data points. And by the use of SPC methods, they are identifying the outliers, and they are either stopping the machine or giving you a signal, or either they are adjusting the parameters by themselves. Okay, so you suddenly recognize you suddenly recognize if the dimension goes out from your control limits, and if, for example, maintenance needed, you just stop the machine and you do the maintenance. Or if it can be fixed by the parameters, you just do the fixing with the adjustment, you do the fixing. So think about it, real-time SPC charts, it is coming into our life. As I said before, normally SPC is done after you machine the part and you measure it. You take samples, of course, you cannot measure all the population, and you try to draw the control charts. But here we are talking about real-time SPC, okay? And with whole population, not with samples. This is the help of data analytics. And visual inspection. Also, it is with the help of artificial intelligence. Now, what companies are trying to do, even in assembly lines, this is actually applied in process, but now in assembly lines, also it is applicable. So you can detect a misassembled part, or you can detect a miss part. Okay, so think about it. When you are going to the team leader, why are we going to the team leader whether the part is correct or not, or correct or wrong, right or wrong? Just take a picture and ask to the artificial intelligence whether it is a mistake or not. I am sure 90% of the time, you know, AI will make better decisions than your team leader. So, as I said, in most of the manufacturing industries now, it is becoming day by day popular and popular in automotive industries, in electronics manufacturing. So, in the paint shop, a surface inspection, for example, or in the welding station, any missed welding points, or think about a semiconductor manufacturing, defective or missing printed circuit board. So very small boards, and it is very hard for operator to recognize it. But you can teach artificial intelligence by using neural networks or machine learning algorithms. You can teach the good part, and the system can easily recognize the wrong part by its learnings. Okay, the AI and ML is very different than coding the system. You are not coding the system. Coding the system is like, say, the traditional and the old way. Now you are just showing the system the good part. Actually, he is knowing the good part. The system is knowing the good part because you are sending the data and you are training the system, training the neural network. And when he recognizes an abnormality, the system gives you a signal or just stops it. And continuous improvement. Again, I came to the y equals to f of x. So what we have discussed, we said that we have to take some data-driven decisions. So we are all technical people. We know that every output is dependent on some input. So what we have to do, we have to identify vital fifths. We call it vital fifths in Six Sigma. So these vital fifths are, there might be a lot of independent variables that affecting your output, but some of them, we call it vital fifths, are very, very important, and you can develop a model with them. So what we have to do, we are trying to understand developing model and trying to find root causes for the problems. Okay, so just one example. For example, think that you have an output, it is a numerical one. And you have a numerical input. So what do? We do we might do graphical analysis for scatter plots. Scatter plotting, by scatter plotting, you can visualize the correlation. You can do correlation analysis also. There is something called correlation, and it is represented with small r. Pearson correlation coefficient. So it gives you statistically, it gives you whether there is a correlation or not. But these are old way, these are traditional way nowadays. What we can do more, advanced statistics with regression analysis. We can develop regression analysis model and try to identify the relation function between parameters and output. Okay, so think that we have a furnace, and as the output, we are measuring the energy level of that furnace. What might be the axis? The speed of the furnace, the temperature of the furnace, the speed of the conveyor, or what is the output? What is the product type? What are the mixture of the liquid, mixture of the paint? So there might be a lot of different parameters, and we try to identify the relation between them. And with advanced analytics, even sometimes regression analysis cannot be done and doesn't enough. For example, think that we have big data. We have a lot of data, and you cannot analyze that data with regression analysis. So machine learning algorithms and artificial intelligence techniques come in that point, and they are like one step further than regression analysis, and they help you to identify the models. Okay. Yeah. So last words. Data science uses techniques in different levels. So there are different, when we call data science, we have different kind of techniques. We have different levels of techniques. from basic statistics to complex advanced analytics, such as machine learning and AI. So these terms are coming into our lives. With the development of Industry 4.0, actually, with the developments that we faced in recent years. Now, companies start to implement these things more and more. And huge cost reduction, jumps in quality levels, customer satisfaction might be obtained with very little investments. So that is the best way. That is the best part of it. That is the best part. So the owners like it, the partners like it. So you don't need to buy, you don't need to invest a lot of things. Even Google, Microsoft, provides you this as a service, machine learning, artificial intelligence. And even these sensors, CPU, are not that expensive. So with a little less effort, with a little cost, you can obtain huge improvements. And now companies are reviewing their HR talent acquisition policy. And every day, day by day, in the future, you will be hearing it a lot. They are looking for data scientists. They are looking for someone who knows machine learning algorithms. They are looking for someone who knows regression, who have green belt certificate, these kind of things. So statistics, data analytics, and computer science becoming day by day popular and popular, and HR companies developing their HR policies regarding to that. So, and they should do that. They should get ready for the future. So, actually, this was all from my side. Thank you. I would like to hear your questions. Of course, it's a very, very broad subject. In half an hour, I try to make a summary. And if you have questions, I would like to hear it.
Thank you, Mr. Shan. You have two questions in the Q&A box. One says, what type of people should I recruit for such kind of activities?
Okay. Yeah, now I've seen. Okay, what type of people should I recruit? So actually, this becoming a job title, data scientist and data analyst. But basically, we are looking for people that know statistics and that are good in computer sciences. So these are the basic two skills that if someone doesn't call himself a data scientist or data analyst, you can just look at the hidden keywords. Statistics, computer sciences are the most main important skills. And of course, you will be having the process knowledge in your company. How could you implement data collection in a labor-intensive production line? It's a very good question, actually. It's a very good question. So it was before mainly for the process, but now it is not like that, Mr. Ali Al-Madid, because now with the help of sensors, with the help of IoT kits, even there are some IoT kits, they are ready. So that you just plug in into your machine, or you just plug into your sensors to the assembly line, and you will start visualizing, you will start having the data. It is not that complex. So what you can do, you can look for these kind of, even startups are doing that. You can look for some companies, I think in Qatar we can also find out, to gather data and to establish MES system in labor-intensive production line. And I'm sure you're gonna find it. Any more questions? Okay. If not, thank you very much for your participation and time. I hope you liked it. As I said, it's a very broad subject. I just wanted to make a brief introduction, what is data science and what is the relation with Lean and Six Sigma. I hope you enjoyed it. And by the way, you can always reach me from my LinkedIn account. And if you have any further questions, you can ask me from there.
Thank you so much, Mr. Chan, for the great workshop. Our dear audience, thank you for supporting our event by attending and contributing. We hope you enjoyed the experience and received beneficial information. See you in our future workshops. Thank you.